Every sample has a story to tell, and PhotonAssay tells that story for gold, silver, and copper more quickly, safely, and accurately than ever before. After being dried and crushed, each 500-gram sample begins its journey by being sealed into a reusable jar and labeled with a unique barcode for full traceability. The jar is then weighed, scanned, and placed on a conveyor system that directly feeds into the PhotonAssay unit. Jars can be queued up in advance for hours of automated operation. From here, the automated robotics takes over. The control system reads the barcode, identifies which analysis services are needed, and feeds the jar into the unit. At the entry point, each sample is automatically paired with a precision reference disk that acts as a calibration standard, ensuring consistent and precise analytical performance time after time. Together, the jar and reference disk are carried towards the activation chamber, the heart of a PhotonAssay unit. Once it arrives, a heavy plug seals it in place. From this moment on, everything is fully enclosed, interlocked, and monitored. If any door or seal isn't verified, the electronic X-ray source that activates the sample simply can't operate. Inside the irradiation chamber, a high-energy linear accelerator, or LINAC, produces short, precisely timed pulses of high-energy electrons. These electrons hit a target, producing bursts of X-rays to activate the sample. These high-energy X-rays easily penetrate throughout the whole sample, unlike low-energy analysis methods such as X-ray fluorescence, or XRF. PhotonAssay directly excites atomic nuclei of specific elements, including gold, silver, and copper. When those excited atomic nuclei decay, they emit gamma rays, with each element having a distinct energy signature that is measured to determine exactly which elements are present and in what quantities. By adjusting the X-ray energy and timing, the same system can analyze gold, silver, and copper with automatic inter-element corrections to ensure accurate results, even in complex polymetallic ores. The activation phase typically lasts between 15 and 40 seconds, depending on which elements are being targeted. The half-lives of the activated nuclei are very short, ranging from seconds to a few minutes. This means their activity can be measured quickly and decreases very rapidly after analysis. Once activated, the sample is moved quickly to the detection stage. Here, ultra-sensitive, supercooled germanium detectors precisely measure the gamma rays emitted from both the sample and the reference disk. These detectors are the gold standard for high-resolution spectroscopy, allowing PhotonAssay to easily distinguish between the signatures of gold, silver, copper, and the reference disk elements. The result is an accurate, repeatable measurement of the full 500-gram sample, with all quality control and quality assurance data logged digitally and in real time. From irradiation to final analysis, each complete cycle takes under 2 minutes to complete. After measurement, the sample remains inside the PhotonAssay unit for a controlled cooling period, typically around 2 hours. Whilst the sample activity levels are very low, even immediately after measurement, the additional cooling time allows any residual, short-lived activity to completely decay. By the time the sample reaches the exit conveyor, it is completely safe to handle, store, discard, or remeasure as required. Assay results are delivered digitally within minutes of a batch ending, complete with an instrument precision value calculated specifically for each sample. PhotonAssay also automatically performs a range of quality control checks and flags any samples with unusual properties. For example, these include samples with high levels of naturally radioactive uranium or thorium, which lead to decreased analysis precision. Samples where a correction is automatically applied for the presence of interfering elements, such as those used in the reference disk. And unusually heterogeneous samples, typically indicating the presence of coarse or nuggety gold. All results integrate seamlessly with Laboratory Information Management Systems, or LIMS, and Mine Information Systems. Extensive comparisons across a range of certified reference materials show excellent agreement with PhotonAssay for all ore types and grades, with a correlation greater than 0.99. For gold, the lower limit of detection reaches 0.01 parts per million, or ppm, and samples up to 35,000 ppm can be measured. The relative precision is around 4% at 1 ppm, comparable to PhotonAssay at the same grade. For silver, the detection limit is around 3.7 ppm, and for copper, about 30 ppm, with excellent linearity across the analysis range. Each unit can process up to 72 samples per hour. That's more than 1,600 per day, or 40,000 samples per month, and throughput can scale up or down as required with minimal staffing changes. Blank samples and certified reference materials, or CRMs, are used to validate instrument performance, precision, and calibration in real time. PhotonAssay results are routinely included in JORC and NI 43101 compliant resource and reserve statements, trusted by qualified and competent persons and regulators worldwide. Machine performance is also benchmarked globally, ensuring consistent calibration and traceability across the entire fleet. This is monitored with live specialist support 24 hours a day, 7 days a week. To learn more, explore case studies, or connect with a PhotonAssay specialist, visit photonassay.com.